Welcome you all to Alpha and Omega Mathematics by Vijay Jackson. Let us see the topic factorization of polynomial over finite field. In this, we have the remainder theorem. The remainder theorem says A belongs to F. F of x belongs to Fx. Just to take a polynomial, Fx belongs to Fx. So then A belongs to capital F. Then the remainder theorem says the polynomial f of x is divided by f of x is divided by x minus a. Then f of a is the remainder. F of a is the remainder. So this is called remainder theorem. Remainder theorem says a polynomial from fx, a belongs to f element, then f of x is divided by x minus a is a factor, then we can say that f of a is the remainder of the given polynomial. This is called remainder theorem. Then the factor theorem says the same polynomial, just to take it, f of x belongs to fx and an element a belongs to f. Factor theorem says a is a root of f of x, then if and only if x minus a is a factor, of f of x. So a is a root of the polynomial f of x means we can say that x minus a is a factor of f of x, and also the reverse part, x minus a is a factor of f of x, then we can say that a is a root of f of x. So based on that we'll do a problem. So the question is what is the remainder? What is the remainder when f of x equal to x to the power 5 plus 2x to the power 3 plus x square plus 2x plus 3. This belongs to set 5 of x is divided by x minus 1. This is the question. So what is the remainder? We are going to calculate it. The remainder, so when the polynomial f of x is divided by x minus 1 over the field, finite field set 5 of x. Okay. So by using remainder theorem, the question is, solution is by using remainder theorem. So see here, f of x is divided by x minus 1 means the remainder theorem says f of 1 is the remainder. By using remainder theorem, here f of 1 is remainder. F of 1 is the remainder of fx. Okay. So f of 1, how we calculated f of 1? So in the given polynomial, f of x is equal to x to the power 5 plus 2x cube plus x square plus 2x plus 3. So in the given polynomial, put x equal to 1. So f of 1. This is the remainder answer. So 1 power 5 plus 2 into 1 to the power 3 plus 1 square plus 2 into 1 plus 3. So the answer is 1 plus 2, 3, 4, 6 plus 3. It is 9. So the remainder is 9. But see here, our finite field is set 5. Set 5 elements are 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So 9 is not belongs to set 5 of x. Therefore, here rearrange it. So this is congruent. Mod 5. So after taking mod 5, so 9 is congruent to 4 mod 5. 9 divided by 5, the remainder is 4. So therefore, now we have got the remainder. The remainder of the polynomial is 4 over set 5 of x. Over set 5 of x, the remainder answer is 4. So otherwise, the remainder is 9, like that. Okay. So over the finite field, over a finite field, we are calculating the remainder. So the next question is, so what is the remainder? Question is, what is the remainder when f of x equal to 2x cubed plus x square plus 2x plus 3. So this belongs to set 5 of x is divided by x minus 2. So here also one polynomial is given, f of x equal to 2x cubed plus x square plus 2x plus 3, and the finite field is set 5 of x minus 2 factor is given. We are going to divide it, the given polynomial, by x minus 2. We are going to calculate the remainder. What is the remainder of the polynomial? Okay, so solution, take it first write it set 5. What is set 5? 0, 1, 2, 3, 4. Okay, so it contains 5 elements. So starting from 0, 1, 2, 3 and 4. Then we are going to use remainder theorem. So using remainder theorem. So remainder theorem says f of x is divided by x minus a, then f of a is the remainder. So using remainder theorem, f of 2 is the remainder. So calculate it, because we are dividing the particular problem f of x by x minus 2. Therefore, we are finding now f of 2. So calculate it. 2 into 2 power 3 plus 2 square plus 2 into 2 plus 3. So answer is 8, 16 plus 4 plus 4 plus 3. So 20, 27. So f of 2 answer is 27. Check it whether it belongs to f of 2 is 27. So check it whether it belongs to set 5 or not. It does not belongs to set 5. So therefore rewrite it. 27 is congruent to right. So 27 is congruent to mod 5. Set 5 of x is given. The finite field is set 5 of x. So therefore we are finding 27 is congruent to mod 5. So just to take it division, 27 divided by 5, 5 times quotient, remainder is 2. So 27 is congruent to 2 mod 5. So therefore what is the answer for f of 2 is now? It is changed to 2. So therefore remainder equal to 2 over set 5 of x So this way we can calculate it the remainder when a polynomial is divided by a factor. So now the next question is, find the remainder when f of x is equal to x to the power 100 plus x to the power 90 plus x to the power 80 plus x to the power 50 plus 1 is divided by g of x is equal to x minus 1 over set 2 of x. So here the finite field is set to polynomial, given polynomial f of x is x to the power 100 plus x to the power 90 plus x to the power 80 plus x to the power 50 plus 1. So we are going to divide it, this polynomial f of x by g of x. It is x minus 1. Okay. So question is, you have to find the remainder of the given polynomial when it divided by x minus 1. So solution. So write it, what is set 2? What is set 2? Set 2 is 0, set of all positive integers starting from 0, and it contains only 2 elements, 0 and 1. So after that use our remainder theorem. Using remainder theorem. So remainder theorem says a polynomial f of x is divided by x minus a. Then we can say that f of a is the remainder. So using remainder theorem, so here x minus 1, x minus a places it is 1. So find out f of 1. From x minus 1, we are taking f of 1. So f of x polynomial So just to replace it, x in the place, put it 1. So 1 to the power 100 plus 1 to the power 90 plus 1 to the power 80 plus 1 to the power 50 plus 1. So the answer is now 1 to the power 100 is 1 only. Then, here f of 1 is this answer. 1, 2, 3, 4, 5. So f of 1 we have got the answer is 5. So now check it whether 5 belongs to set 2 or not. 5 is not belongs to set 2 of x. So rewrite the 5. Okay. So rewriting 5 here. This is congruent to 5 is congruent to mod 2 here. Okay, because our field is set 2. So 5 is congruent to mod 2. After dividing, actually 5 divided by 2, quotient is 2 times, remainder is 1. So remainder is 1. So therefore f of 1 answer is now, it is not 5, 1. It is 1. Okay. So therefore we have got answer, the remainder. Remainder is equal to 1. This is over set 2 of x, over set 2 of x. So this way we can find the remainder of the given polynomial when it divided by another factor. So and also you can use that factor theorem. Factor theorem says a is a root of f of x, means you can say that x minus a is a factor. X minus a is a factor of the polynomial. So that is both ways it is true. So this is called factor theorem. So and also you can say that one theorem, the theorem says a polynomial of degree n, f of x, just to take it, it is a polynomial of degree n, then it has at most n roots in f. That is a known concept only. So for example, suppose a polynomial of degree 1 means you will get only one root. So suppose a polynomial of degree 2 means we will get only degree 2. So in general, f of x is of degree n, means it has at most n roots in the field.